Hi, this is Mrs. Sigala, and this is your homework for 4.11, writing ionic compounds, but with transition metals. Okay, so first I'm going to write the oxidation numbers on your periodic table, because again, this is something that we absolutely need if we want to be successful in chemistry. So I'm going to start off with writing group 1, group 2, plus 2. Okay, and when you get your blank periodic table of elements, make sure you do this right away, okay? All right, group 15 is -3, group 16 -2, group 17 -1, and group 18 is 0. Okay. All right, so we know that transition metals are found in groups 1 through 12, and there are also some transition metals that are kind of a little dispersed, okay? But don't worry about those, because again, when you have the name, you'll be given some information, okay? So the only true metal in this case, to the left of the zigzag line, is aluminum. Okay, everything else can be considered a transition metal. Okay, and we'll see how that works here shortly. Again, I'm going to separate my metals from my nonmetals. My nonmetals are going to be to the right of my zigzag line, and my metals will be to the left of the zigzag line. And again, transition metals are, they're a little complex sometimes, because again, their oxidation state can vary. Sometimes it can be +1, +2, +6, +3. You just never know. It depends on what it's bonded to. All right. So the way that we identify transition metals is we always look for a Roman numeral. Okay, that Roman numeral tells us some information about that transition metal. Okay, so that Roman numeral tells us, it tells us the oxidation number, or oxidation state or charge for that transition metal. Okay. So it's very important. All right, so here we have tin. All right, my symbol for tin is SN. According to my Roman numeral here, I have 4. So tin has an oxidation charge of +4. Fluorine, is in group 17, so it has an oxidation number of -1. Okay, so I'm going to write all those down first. So chromium, okay, 3, because of its oxidation number is +3. Oxygen is -2. Manganese, according to this, is +2, because metals are always cations. Sulfide, sulfide will be -2. I have copper 2 nitrite, so Cu, oxidation charge of +2. Nitrogen has a charge of -3. Have lead 2 oxide, so Pb, charge of +2. Oxide, O, and oxygen has a charge of -2. Lead 4 oxide, so Pb, +4. Oxide has a charge of -2. Titanium 3 chloride, so titanium +3 chloride, and chlorine has a charge of -1. Tin 2, so tin SN, +2. Sulfide has a charge of -2. Iron 3, again iron, Fe. Because of that Roman numeral 3, my oxidation number is +3. Selenide, again, because selenium is found in group 16, is going to have an oxidation number of -2. All right, so basically we're doing the same thing we've been doing with ionic compounds, ternary acids, polyatomic ions. We're using the crisscross method. We're going to be using the crisscross method for everything except for covalent compounds. Okay, so again, I'm going to use my crisscross method. So this 4 goes in front of my fluorine, this 1 goes in front of my tin. So my formula is SN. I do not need to write the 1 because there's only one. F, and then 4. Again, this 2 goes in front of my Cr, this 3 behind my oxygen, so my formula is Cr2O3. We can't simplify. This is the simplest as we can get. But here, however, when we do the crisscross, we have Mn2 S2. Here we actually can reduce to 1. So when we reduce them to 1, we do not have to write those ones down, so my formula would be simply MnS. Again, I'm going to cross here. My formula will be Cu3 N2. It's already simplified. Again, this 2 goes in front of the lead. The 2 goes behind the oxygen. I have Pb 2O2. Because these are the same, I can simplify or reduce, so my formula will be PbO. Okay, here my 2 goes in front of my lead, my 4 behind my oxygen. I have Pb2O4. Both of these numbers are divisible by 2, so we can reduce them, so my final formula will be PbO2. Now, next, my 1 goes in front of my titanium, my 3 behind my chlorine, so it's TiCl3. Again, Sn. And the more you do this, the more you'll be able to recognize, wow, some of these I can reduce. Okay, and you can identify them right away. Okay, last one. Again, I'm going to do the crisscross method. Fe2 Se3. Okay. All right, so now at the bottom, again, I went ahead and included the periodic table, your polyatomic ions, and your prefixes because everything's mixed practice. So we covered transition metals today. So again, the easiest way to identify them, well, they're going to have these Roman numerals. Okay, so here we have, again, transition. Okay. Next, the easy ones to identify, again, acids, acid, and that's it. Okay. Next, we can identify covalent compounds right away. Let's see if we have any covalents. Here we do, because again, we have prefixes. Trihydride, covalent. That's pretty much about it. And next, we have polyatomic ions. Again, 8 perchlorate, that's definitely polyatomic. And peroxide, even if it's not on your list, it is behind the list on your white periodic table of elements. And last but not least, we have ionic compounds. And again, here you want to confirm that you have a metal, and here's barium in group 2, along with a non-metal, and here's chlorine in group 17. Alright, so I'm going to follow my rules again. Since we just covered transition metals, those are fresh in my mind, so I'm going to finish transition metals first. So I'm giving copper 3 fluoride. So copper 3, which means it has an oxidation charge of +3. Fluorine has a charge of -1. I'm going to crisscross these. I'm going to end up with CuF3. Next I have chromium 3 oxide, Cr, that Roman numeral is 3. So my oxidation charge is +3. And oxygen is -2. I crisscross. I end up with Cr2O3. Alright, next I'm going to go ahead and look at my acids. And again, I like to start off with my binary acids. Here I see the prefix hydro, so right away I know that that's binary. So again, all my acids begin with hydrogen, nitric, N. I'm going to look at my oxidation charges. I'm going to crisscross them. So my formula is H3N. My next acid is a ternary acid, OUS. Again, I'm looking at polyatomic ions. Because it ends in OUS, I'm going to revert to ITE. So we're looking for sulfite. Again, all hydrogens start with hydrogen, but I'm going to look for sulfite on my table over here, and here's sulfites. SO3 with a charge of -2. Hydrogen has a charge of +1. Again, I'm going to crisscross. So my formula will be H2SO3. Okay, next I'm going to finish my covalent compounds because these prefixes tell me how much of what I need. So here it's dinitrogen, that's 2 nitrogens. Pentoxide, that means 5 oxygens. Phosphorus trihydride, phosphorus, there's no prefix, so it's automatically 1. Hydride, that's for hydrogen, it's tri, so there are 3 hydrogens in there. Last but not least, I have my polyatomic ions. And again, oh, no, I'm sorry, not last but least, but let's do iodine. Let's do ionic compound first, sorry. So I have barium. Barium, you can be found in group 2, so it has a charge of +2. Chlorine, group 17, so it has a charge of -1. I crisscross these, so I have BaCl2. Alright, last but not least, for sure this time, we have polyatomic ions. And again, I have lithium, so I'm going to write down my metal, lithium. Group 1, so it has a charge of +1. Perchlorates, on my list, it is, oops, here it is, ClO4, and it has a charge of -1. I crisscross these, so my formula stays basically the same. So it's ClI, ClO4. Last, I have sodium peroxide, and peroxide, this is the polyatomic ion with a charge of -2. So again, sodium is in group 1, so it's a charge of +1. Peroxide is O2, has a charge of -2. I'm going to crisscross these. So my formula will be Na2O2. I'm sorry, just O, because that 1 stays there and we don't have to write it in.